Hello and welcome to my webinar on the 5 ways to slash your data platform costs. My name is Chris Santiago, and I am the Global Director of Solutions Engineering for Unravel Data. I've been with the company since January 2016, and throughout my career here at Unravel, I've helped large and small folks starting from Fortune 500 enterprise customers all the way to customers that are just starting their big data journey into the cloud. If you are hearing about Unravel for the first time, Unravel is an big data specific APM solution, ultimately helping customers simplify their big data operations. So when I first get involved with customers, lots of things that they want to see and have our tool help them. But there's always one common challenge, one common theme that always comes up throughout our customer engagements. And it's how do I slash my data platform costs? It's a challenge for big, for small, and it's something that I don't see going away for the foreseeable future. So, in my experience, I've worked with a number of different scenarios, and throughout this, I'm going to present you 5 ways that have helped my customers slash their data platform costs, and how a tool like on Unravel can really help accelerate this for your organization. The first thing that I'm going to go into is really starting from the source, and that is those jobs. And when I say jobs, I'm talking about those Spark jobs, your Hive jobs. Before we talk about cluster, data platform cost cutting measures, we really need to start at the source. And why that's so important is because when you look at trying to optimize things, you need to go down to that lowest level of work, and that's always going to be the jobs that you're running in your cluster. If your jobs are not optimized, then your environment is not optimized and will be wasting resources left and right. In my experience working with numerous development teams, some common challenges, bad practices that I see certain development teams do is when they see that their jobs are failing or they're not getting the performance that they need, the first thing that they'll do is throw more resources at it. And that's an easy fix, something where, hey, if I just need this job to run, I'll go ahead and just throw maybe double my memory footprint. And while that does help in that one particular scenario, a lot of folks don't actually go back and see, hey, am I actually over allocating my job? Now, if you extrapolate that between, one developer bad behavior, now, essentially the whole team is doing that and they're managing multiple workloads, you can see how this actually adds up. And generally speaking, when we work with customers, we're looking at sometimes 30 upwards to 50% of resources that we're seeing just for the developer just to spend a little bit more time on their jobs to either configure it correctly or maybe fix some of the efficiencies in their code. If they just did that extra step, we could actually get some real cost saving measures. But that leads me to my second state here. So getting to an efficient state really requires a trial and error approach. When the developer is working on their job, in order for them to find what that optimal setting is, there's nothing there to forecast what is going to be your next best setting there. They have to do this whole trial and error effort. To make matters worse is you've got folks where they may be working on jobs that have varying data volumes, or maybe you're in an on-prem environment and you're always fighting your tenants for other resources. I mean, there's so many different variables that even if you went down this path of trial and error to figure out, hey, I'm just trying to do the right thing and I want to make sure that my applications are sized appropriately, that's challenging. And even worse, time and resources wasted every single time that you run that particular job to get there. That's a challenge for folks that are really trying to make their jobs most efficient. And finally, there really is no accountability for those development teams, right? So going back to my first example, where you've got a developer that doubles memory every time that his job fails, there's not a platform team that's really going in there and saying like, hey, you're actually way grossly over allocating your job. There's nobody really there to, or no metrics really there to really kind of just show, or even just say that there could be an opportunity for efficiency gains. for that particular job, and it goes unchecked. And so that becomes a challenge. So how do you fix this? Well, you need to enable your development teams with a tool that can give them, first of all, the right visibility to understand how that job is running. And then what if there was a tool that actually proactively gave them some of these recommendations so they can forego the trial and error approach, and then also just provide visibility to overall the data platform team that, like, hey, there are some jobs that are grossly inefficient that we can actually fix. There is a tool, and that tool is Unravel. What you're looking at right now, I picked a Spark application because that's a pretty popular engine that most people use nowadays. We first start off with visibility. So as that developer, if I wanted to understand, did I get all my right resources, I could see for my particular job, I can see that here. So in terms of compute, in terms of vCore, in terms of memory, if I want to even get a little bit more fine grained, I have the ability to select things such as like OS level memory for my executors and drivers. And so a common resource efficiency pattern that developers may do is, which size of my executor should I actually set this on the job level? Because if I set it too low, then my job's going to fail. If I set it too high, well, it'll be successful. But if I set it up too high, then I'm going to be grossly wasting resources. And if this is an on-premise environment where I'm sharing resources, like in a multi-tenant cluster, I'm not being fair to my other tenants. And then if this is something in the cloud, I'll be asking for beefier nodes that I don't necessarily need. We always first start off by just showing where the opportunities lie for visibility for the code. I'm going to cut to the chase here and really kind of just show our bread and butter here in terms of some of the insights and recommendations that Unravel is able to provide. And so behind the scenes, not only are we giving the application developer all the metrics, tools, et cetera, and so forth on what they need to really understand how that particular job had run, but we're also going to be proactive in nature and actually provide recommendations. In this particular case, I'll highlight a few. Is we've got a recommended configuration available for resource efficiency. How you read this is we've got this current value of, he asked for 5 gigs. But we had seen that in that chart, we didn't even get close to 5 gigs. It was a gig. And so you can see our recommended value here is more aligned to what was actually being used. I've seen, some companies at some large organizations where they may be grossly over allocating things and from a memory standpoint by like 40, 50 gigs. And they have these long running jobs that are spinning up 100, 200 executors. And we're able to provide these crisp recommendations. So that way we're able to go and give you those recommendations. Number 2, ensure the right server resources are selected for your job. Is going to be a little bit more cloud oriented, mainly because on-prem folks, if you guys want to add more hardware, it takes a little bit of time to just add more nodes. So this is going to be a little bit more applicable to our cloud friends here. But for you cloud folks that have embraced the cloud, adding more resources from a server level is as easy as just adding your configuration file, requesting it, and then the cloud spins it up for you. So that's a very great advantage that the cloud brings that I'm sure that you guys are aware of. But with that great power becomes even more responsibility in the fact that you need to ensure that you are selecting not just making sure that your job is running efficiently, but now you got to look at this from a resource level, from a server level. If you look at I just pulled this up just from AWS. If you look at all the instances here, there are so many. And so now you're adding a level of complexity of if your sole purpose is to ensure that you're selecting the right resources that are really right sized for your job, that's just one more thing that you need to calculate, right? And so do it wrong, and you can see some inefficiencies, and you'll ultimately pay the price, right? My next example here is actually Unravel in Databricks, very similar to what you had seen in my first tip, where we're able to provide the visibility into how that Spark application had run. But I'm going to cut to the chase here, right? With Databricks, not only are you submitting your code, but you're also, in this particular case, this is a job cluster. When you're about to submit this code, you also have to provide some parameters into the instance types that you want. Maybe auto scaling might be something that you may want to add to as well. And so you'll set that in the infrastructure level. And then from there, auto scaling is a very powerful feature but it's only going to be looking at things from an infrastructure level. Say, for example, you had taken a compute heavy node, but your job is actually pretty memory intensive, right? And so what's going to happen is you're going to auto scale up even more nodes just to kind of make up to get to the number of memory that you have that you need. You're doing that on the VM level on a cloud technology like Databricks. And so what can you do? Well, not only do we have recommendations on that job level, so that's straightforward. For tech stacks that accommodate setting up the parameters on that VM level, we'll provide recommendations on that too. And so here, what you see here is you've got this cost instance recommendation here for this particular Databricks job. Just to set the stage here, I had previously asked for D64 V3s, which are very, very heavy. They're 256 gig memory, 64 core vCores. And because that's such a beefy node, there's going to be a beefy price associated to that. So that's $487. Based on the analysis that Unravel was able to provide, we were able to actually recommend these DS3 V2s, which are really just 14 gig memory, 4 cores. And that costs 40 cents an hour. On the life of this application, if we were just to use this particular instance, application would have ran just like it did before, but we would have actually had saved $1,786, right? This is just one instance run, right? If this is a data pipeline job of one of 10 steps, and then this data pipeline job runs every day for 365 days a year, you do the math, right? And so from a cost saving standpoint, not only do you want to make sure the job is ensuring that you have the correct resources, you want to make sure that from a VM level, you want to be able to make sure that you're sizing your VMs appropriately for the job. So that way you're not wasting any resources. And then obviously that helps reduce your data platform costs. Number 3, choosing your clusters based on workload. This particular tip is going to be custom for folks that possibly could be on-prem or they're already on the cloud, but now they're kind of rethinking their platform and they're looking at their options in the cloud. And there's a lot of options, as you guys know. But right now, we're going to focus in on 2 architectural decisions that I see a lot of customers gravitate towards. You've got folks that may spin up ephemeral clusters. So ephemeral clusters are just short run clusters that spin up and spin down based on the life of that particular application. So think of it as like a cluster that is just specific to one specific use case. Ephemeral clusters are very, very powerful because this is a good use case for productionalized, scheduled jobs. So I already know what the job's going to be doing. This could be more for an ephemeral model where I've got this Hive job that's going to run. It's going to do some transformations, do its job, and then spin back down. The other thing to think about is if you have, resource requirements. So say, for example, you've got a very bursty data science model that needs to run, at 8 in the morning every day. And then that's it. You don't need to run it anymore. It doesn't make sense for us to have this as a long-running cluster because you would always have to plan your cluster for the max, usage. And then there would just be a lot of resource wastage because you wouldn't be using those resources. If you have like small, medium, large type workloads, let them just spin up themselves, do its job, spin back down, no harm, no foul. And now you're really taking advantage of some of the cloud native features. With this ephemeral cluster approach, it really focuses on single tenant type architecture. No more fighting for other resources from my other tenants. This cluster is mine, all mine. Let me do whatever I need to do, and then so be it. If you are able to do that, ephemeral clusters are going to be a good architectural choice for you. The next one is long-running clusters. Long-running clusters definitely has its own place. If you are on-prem today, you have no choice but to have long-running clusters. But if you're in the cloud, there still is a use case for having long-running clusters. So if you have workloads that are very interactive in nature, so think of things such as like a data scientist that just needs a notebook that's just always running and it does not want to take it down because there's a lot of complexity going on in his analysis. That's something where a long-running cluster is helpful. I've also seen a lot of customers use long-running clusters for powering like just an always-on reporting kind of framework. We don't want to turn it down. We don't turn it off like an ephemeral approach. It always needs to be running. I mentioned a couple of different scenarios here. Where do you even begin? How do you even know which workloads make sense for ephemeral? which workloads make sense for long running. I mean, you may have an idea, but really the true test here is if you had a report that was actually driven by actual data usage to actually answer some of these questions for you. And so what you're seeing here right now is our, we call it the migration reports because really it's really giving you our insights into replatforming your current existing architecture. And if you're trying to decide, should this be ephemeral cluster? Should this be long running? You're really only going to be able to get that if you can just drill down even further than just, infrastructure level metrics. And so we do give infrastructure level metrics here just to kind of start things off in terms of, here's your platform that you have today. But then we can take it further. We can look at things by application type. And so here we can see that my MR jobs here are taking up 54% of the cluster. And so if I were to go part and parcel here and bring the whole cluster here, it looks like I have a decent amount of batch jobs here, assuming these are batch jobs. I can look at it by user. So if there's a lot of service accounts, maybe you have your tenants by service accounts. I can go ahead and get that information, or by queue. So I can get that information as well. On the right-hand side here, it's just overall metrics in terms of from the cluster itself, like, hey, how heavily used is this? Is this, in this particular case, these particular instances are very underutilized, right? So, this customer spent a lot of money on their hardware costs, never really actually used it, so they're under provisioned. So we can actually, actually have some savings here if we actually gone with some nodes that have a little less resources because our current workloads don't need all those resources. So I can get that level of detail from here, as well as a heat map. And so to read this, you've got the lighter colors is lighter load, and then you got your heavier colors, that's heavier load. And so this is like a discovery report, right? Before you decide and really choose what your future architecture may be, you really need to get your the high level information first. But let's just say you have a good idea. So then we move on to the next step here. And so we've got this workload fit report where we can actually start saying, hey, this report is very useful for giving us forecasting into maybe bringing this into separate clusters, right? And so instead of like thinking of moving and replatforming this particular big data platform into one, whole one in the cloud, what if we had purpose-built clusters and say, maybe I'm going to do this with just my MR job. So this is going to be a batch cluster, right? I'm thinking this could be something where I can actually provide more an ephemeral architecture might actually be useful for me because I want to save costs, right? And so I clicked on this get heat map view here, and so now this heat map is very similar to what you had seen in that previous report, but now this is going to be very specific to my selections here. So in this case, my ETL jobs, I can see like for the most part I've got a lot of activity here Monday through Thursday between these time periods, and it looks like Saturday. So well, actually starting Friday night, I start probably doing my heavy weekend reporting, and so this needs to be ready for my executives for their Monday morning meetings. And so I can see that this is very bursty in nature, right? And so once I start getting information on that, this is where the fun stuff happens, right? This is where I can go ahead and start choosing the different types of workloads. So right now in my example here, I do have Azure HD Insight. So this is a elastic compute model that's hosted in Microsoft, but this could just as very easily be Amazon EMR, Google Dataproc, Databricks, et cetera, and so forth. But once I have the workload defined up top here, this is where we can start getting some cost saving estimates, right? And so right out the gate, based on actual data usage, we're going to provide very crisp recommendations on the node types that you should be using for these particular batch jobs. And here we can see what they are. So that's 100% SLA. So think of this as just matching what we exactly have in production today. But maybe 80%. Maybe this is more exploratory cluster. It's my development cluster. I don't have to hit the SLAs as aggressively. And so I can get some cost saving measures there, and I can get the instance recommendations from here as well. So now I can start really kind of forecasting what that would look like and start really getting a good idea from a total cost of ownership perspective. Now, let's just say this isn't going to be something where it's going to be ephemeral. Maybe I am going to stick with long-running clusters. If that's the case, then maybe auto-scaling may be good for you. And so we do have some insights into what it could look like if you auto-scaled your cluster based on the actual data usage that you're doing today. And that's what you see here. And so in HD Insight, they do have an auto-scaling feature here. And with these recommendations here, I can see that I'm able to take my $212 an hour original cost, save 18.55% if we enable this auto-scaling schedule, down to $172. And so as we're looking for further ways to cut costs, when we select our architecture, whether that be ephemeral or whether that be long running, we're able to provide some insights and recommendations to really belabor that point of slashing your data platform costs overall. All right, moving on. Number 4, ensure efficiency and performance on your data tier. And so with this tip, one of the things that customers first start off with is optimizing their applications, allocating their resources, making sure there's no resource wastage. But one sometimes overlooked aspect is how are you managing things on the data tier? So, this applies for both on-prem and cloud customers, right? If your storage usage is ballooning out of control, and you have no idea where it's going, how can you address that from an archiving strategy? More importantly, there are some repercussions if you are creating, say, for example, tables that you're going to write your queries on. There's implications from a performance standpoint that can effectively ensure that your jobs are going to be asking for more resources every time they run, which obviously adds up the cost. And so, one thing that I always like working with customers is I first challenge them with, do you even know how your users are using the data today? And a lot of times they don't. They have some tools that give them a good point in time. This is how things, reside today. But like to be able to slice and dice it by like hot, warm, and cold, by the last accessed, by, hey, is this over partitioned? Are you even using the right partition keys, et cetera, and so forth? That level of detail, a lot of customers don't have it. And if they do, they spent a lot of time doing something custom. And with Unravel, you don't have to do anything custom, works out of the box, and we're able to provide insights on that data level. And so here, what you're seeing here is, in this particular time span, how are my users using the data? So we're looking at, 20% of the tables are being used most of the time, and you've got 74% that are cold. And so if I'm in my on-prem environment and I'm about to add more nodes because I need to have more HDFS usage, well, maybe the next thing I should do first is archive some of the data that I'm not using. Or maybe this is AWS. And so maybe I can move some of this cold data into Glacier storage because it's just not really being used, right? You can start thinking about things in that way. So that way we can start cleaning up some of your exponentially growing data catalogs. The other thing that Unravel can do too is give you insights into tables, some inefficient table recommendations, right? And so, why is this in the cost savings talk here? Well, it's because, again, we want to make sure that our applications are performing efficiently, and if we have inefficiencies on that table level, it's going to make all of our applications globally work that much harder, and they're going to ask for more resources, and you get the gist. That rolls up the cost. And so here we can look at things such as like table missing stats events. So statistics, very important feature. I won't go into details on that, but that's a great way of improving performance. Table inefficient format events. So maybe we're storing our data in text format and we're not putting it into like a Parquet format or an Avro format. There's obvious performance implications there, and there's time, resources wasted from that standpoint. table small files event. This is a big one. So a lot of times folks, especially developers who maybe more on the junior level are writing these jobs and they're creating a lot of small files. Well, it might not be a problem for them when they were writing those files, but for the folks that are going to be reading in those files, and there's, millions of files, and they're only a few kilobytes, size per file. That's a lot of overhead, and this is a problem for on-prem folks because that takes up space on your name node. And everybody on the data platform side here knows when you have poor performing name node, that affects globally everything on the cluster. So that's something that a lot of data platform folks top of mind is making sure that name node performance is top of mind. And small files is one of the main culprits of that. But the cloud folks, you're not immune to this at all either. Like small files in on-prem is the same thing as small files in the cloud. If you're running your Databricks job and it has a lot of small files, there's still a lot of overhead there, and it's something that you need to address. And so, we have reports here to actually show where some of the small files challenges are, and you're able to resolve it from that standpoint. And once you're able to make sure that your data tier is running optimal and performant, then we see less resources used for our jobs, and overall, that always adds up to slashing some of your costs on the data platform side. You really want to take advantage of cloud pricing discounts. Now, this is obviously for the cloud customers that are on the call. So if you are on-prem, I apologize. But one of the advantages of having an infrastructure in the cloud is, there's a lot of incentives from all three cloud providers for saving costs, right? Whether it be reserved instances, so buying some of your instances ahead. Or maybe in AWS's case, they have this concept of spot fleet. And spot fleet pricing essentially means that AWS has a surplus of VMs that may not be used. And if you have a request and you can take advantage of that surplus, AWS is going to go ahead and give you a discount on that. Now, the trade-off is that these are borrowed instances. And so if they're going to give you something at a deep discounted cost, if somebody actually needs those resources, they're going to take it away from your job. So you need to understand like all the characteristics of your jobs holistically, like throughout the life of the applications that you're running. The other thing too is like this really is helpful for that ephemeral cluster use case, right? Where you're spinning things up, spinning things down. May or may not make sense if you have a long running cluster, because if they're taking your nodes away during your long running cluster, that could have some unexpected consequences on the performance and predictability of your jobs. So spot fleets in general, very, very helpful for transient type workloads. And so my last example here is really focusing in on this AWS spot fleet use case. And so what you're seeing right now is our reporting feature, where we're able to provide overall visibility into what's going on with your EMR environment. And so in this particular case, you can see that I've got a bunch of ephemeral clusters. I'm enabling AWS tags. And so that way I'm tagging all of my ephemeral clusters by purpose. So I've got my ETL ephemeral clusters. I've got my QA. I've got my BI. If I actually select on one of these tags, I can actually scroll down and have a good idea of all the clusters that make up that particular tag. And they don't exist anymore because they did the job and they spun down. But I still have that history here too, so I can see what was going on at that application level. So there's always optimizations that we can do on that job level. But what I wanted to really focus your attention on here is this has been running for a month here. We've collected some insights. We're able to give you guys a breakdown of costs, whether it be from EC2, EMR, EBS, what that total cost is. What I can see here is that my ETL jobs are taking up a lot of resources, 61% to be exact, and $22,000 of my spend for this particular month. And so, if there's anything that we can do, hint, spot fleet instances, spot fleet pricing, to really help maybe drive these costs down, I'm sure that customers may be interested in that. So let's go ahead and take a look at that. So in order for me to do that, I'm going to go ahead and click on this Insights tab here. And so this is going to run. And so it generates a report. And so based on that same time frame here, we do have some insights. And so in this particular case, for my ETL transient clusters, we noticed that this particular instance has low spot interruption rate. So it's not always going to be taking my instances. So okay, that's good. And by the way, these particular applications and this workload are short running. So okay, that's even better. Like this seems like it's a good candidate for doing some spot friendly workloads. And so here we can see today, if I just do it as is, it's $781. But if I were to switch to spot instant pricing, you can see this goes way down to $273. And you're saving about $508 for each time that this cluster is used. And if you roll that up for that month time frame, we're talking $15,000 savings. That's a lot. And so, your mileage may vary, but we're doing the analysis for you. And so instead of you kind of doing the guesswork of like, is this going to adversely affect me, or like, will this actually help me save costs? We're doing that analysis for you, and we're giving that to you. Last one here is kind of similar to what we were talking about on my second tip in terms of optimizing resources on that cluster level. This is doing the same thing, but it's actually sampling the transient clusters and saying, like, out of all the transient clusters, you're always using this R5 4x large. You can actually use the 2x large, no problem. And so that saves you $351 each time this cluster is used. And then there's additional $10,200 of savings just by changing an instance type. So just by going into your configuration in your EMR cluster and saying spot friendly workload, different instance types, we're talking close to $25,000 potential savings if we were to run this. In today's talk, we went through 5 different scenarios to slash your data platform costs based on my experience working with customers from an on-prem and a cloud standpoint. I hope that you found some value in this. Because this is pre-recorded, I won't be able to take your questions, but I've left my email here in the presentation here. Feel free to email me with any questions that you may have. And I hope that this is beneficial for you and that you are able to slash your data platform costs for your organization.